Yes, thank you. Uh, I'm called Watmon Derek. I'm presenting my project in database system, presenting hospital management system, the institution of Mbara University of Science and Technology. I've chosen hospital, and in hospital we have various databases applicable in hospital. We have hospital management system, electronic health record, laboratory information management system, pharmacy management system. And the reason for choosing this area, I've chosen hospital management system because first of all it provides a comprehensive patient data management system. So it also improves hospital efficiency by reducing paperwork. As we all know, this is a digitalized system. Then it also ensures data security via platforms, for example, the password, where the users before obtaining information, they first enter their details and credentials. And then also we say it provides scalability, where as the size of the system increases, it does not influence its performance. Then we say the application domain. You have the secure storage of patient medical records, where we say patient records are being stored in a secure way. Then there is a system. We say it assists also doctors in accessing patient history and prescribing treatments, where we have said that doctors can interact with the system and obtain the patient history so that they can efficiently prescribe treatments for each of these patients. And we say that help administrators in scheduling and billing, where we say scheduling or the time scheduling here enhances in reducing overloading on the doctors, and also it enhances patient quick recoveries via efficient treatments which shall be delivered timely. So the system helps us in scheduling that, and therefore a good recovery. Then when we look at slide 5, we say that the benefits of the system can either be tangible or intangible. For tangible, we can have faster retrieval of patient records, where administrators can interact with the patient record via the system and obtain faster retrievals. And then we have automated appointment scheduling. As we have already said, this scheduling helps for efficient, timely treatment of the patient, and therefore quick recovery. We say that there is what we call improved accuracy. Since these doctors will interact with the patient's records and obtain the required patient history, and thus also make decisions on the right prescription. The intangible benefits, we have better decision making for doctors, where we say these doctors will make better decision via each of these patient history. And then we also say there is an enhanced security for patient data via provision like entrance of password before interacting with the system, such that each of these patients are recognized with their own password. Then we also have improved patient satisfaction. The system will help each of these patients to get satisfied with each of the details. Like for example, a patient might interact with each of the doctor at a time being scheduled. Therefore, it enhances timely interactions of patient with the doctor, which improves his satisfaction in this case. We also have in slide 8, there is what we call risk assessment of the system. The system can also have some risk or problems associated with it. We can also have technical risk, where there is data security breaches. The data security breaches could arise due to hacking. The system is digitalized and works via internet. Therefore, it can also be hacked at some one point or the other. Then there is what we call system downtime. Like for example, if the centered system got problem or it had some challenges, the whole of the system could come down and could fail to work. This is a very big risk in the organization. Then we have organizational risk, where there could be staff resistance to new technology. Other staffs are primitive and could not easily adopt new changes to this technology, and therefore this would influence this system uses in these various hospitals, like in rural areas. Errors due to improper system use. Other staffs could lack knowledge in using this system, which would lead to errors in this case. Then there is system limitation, where we have the system requires stable internet. As we have already said, there could be challenges of unstable internet, and the system also at the same time requires stable power supply in this case. The stable power supply here would help the system to run in a good condition, but when the power supply is unstable, the system could have some problems. Then we also have high initial investment for system setup, where we say we need to buy this software and hardware at high cost. Okay. When we go to the next slide, database design. So here we have used also the logical design, where we have the entities, relationship between them, and the attributes. The entities that we have here includes patients, doctors, appointments, treatments, bills, and the key attributes for each of these entities are found in the ERD, where for patient we have all these: patient ID, name, age, gender, contact, where patient ID is the primary key. When we come to treatment ID is the primary key, whereas patient ID, doctor ID are all what? Are all foreign key. When you come to appointment, just the same. Appointment ID becomes the primary, whereas patient ID, doctor ID are all foreign. The same to bills, these are the attributes. And also for doctors, those are the attributes. So those are under key attributes of each of these entities, please. When we come to database design relationships, patients to appointment as one to many. So when we look at most of this relationship is a binary relationship, and then also these patients interacts with appointment in a one-to-many relationship. So most of this relationship is a one-to-many. Doctors to appointment, one-to-many. Patients to treatment, one-to-many. Entity relationship diagram. When we look at this entity relationship diagram, it gives us the details of how each of these entities interacts. These are all one-to-many. The interpretation here is based on the arrow. where this is the description of the relationship. For example, when we take patients and appointment here, so one patient can have many appointments. So when we look at patients and appointment, one patient can have many appointments. So the relationship here is can have, and the cardinality is one to many. So the patient ID in the appointment here becomes a foreign key which relates the two tables. So the same applies to patients and treatments, doctors and treatments, doctors and appointment, and then patients and bills. The physical design, these ones here are used like for creating and designing the table and the whole database. Like for example, when we are creating table patient, we use this syntax: create table patient, which is the table name, and then the list of the attributes. That is just an example of one of the physical design, but we had many physical design like in creating many tables. We also created other tables like appointment and etc. Sample queries. So we had these queries which would retrieve specific data from the database. The first query here is queries to display. This one is supposed to be display to display all patient records. So this query would help us to quickly access patient information, since all patients visiting the hospitals are registered with their details, including ID, name, among others. So as you know, the moment we retrieve all these patients' records, we are positioned to get information for all the patients visiting the hospital. So queries are very helpful. We have some of the queries like list appointments for a specific doctor ID. This one helps us to assign or schedules doctors accordingly to their time. The total bills, the query that shows total bills for a specific patient. This one here helps us to actually know how much a patient should give before a discharge of the patient. As we come to the conclusion, we say that this hospital management system provides an efficient, secure, and scalable system for managing hospital data. So it's efficient and secure, at the same time scalable. Then we say the future improvement, it enhances security, integration with other systems. So the security could actually be enhanced via the interactions, how the users would interact with the system. Like if we look at this point, before the user interact with the system, you have to first enter your username, password, and then you log in. So I think this is my presentation, this database. Thank you very much, dear sir.